I'm Jerry Brinkley.
Cameron Hughes.
I'm Brandon, and this is a project over electron charge.
Alright. Additional facts. I listed a couple of facts here. Fact number one, Millicon is best known for the oil drop experiment, which measured the charge of a single electron. Fact number two, he won the Nobel Prize in Physics in 1923 for his work. Some other work is Millicon also studied cosmic rays and photoelectric effect measurements. Uh, Collaborators, some people he collabed with was he worked with Harold Fletcher and other students during his experiments on the electron charge. Related information is Millikan's precise measurement of the electron charge helped affirm the quantization of the electron charge, or electric charge, a cornerstone of modern physics. Additional interest, interesting, surprising fact I found is fascinating that Coulomb's law, formulated in the 1700s, is still used in every electronics and physics problem today. What I learned is I thought Coulomb's only studied electricity, but he also studied mechanical properties of materials and friction, which influence engineering as well as physics. Further investigation, how torsion balance are used in modern physics experiments, real life applications of Coulomb's law in electronics and nanotechnology, historical development of electric force measurements before the electron was discovered. Come on. Additional interest, how it went. Overall, the project went very smoothly. Collaborating with my partners made the research and slideshow creation enjoyable and productive. The most important part, my key takeaway was understanding how the electron charge works and seeing how the foundational experiments like Coulomb's law and Millikan's oil drop experiment still affects modern physics and technology. Easiest part of the project, working with outstanding and cooperative partners helped the flow of the work, as well as having Zoom meetings to discuss ideas clearly and efficiently. Hardest part, I would say, was making sure all the slides connected logically so the problems, examples, and summaries all flow together without repeating information. Most surprising part, I was astonished on how much of the work we still use today comes from the discoveries of scientists like Coulomb and Millicon. Their experiments laid the groundwork for so much of the modern physics and technology. Relevant sources used, Coulomb's CA 1785 torsion balance experiments on electric forces, historical physics documents. And then another website is Britica. Uh, they also do a lot of other laws as well. You can see the original source digitalized torsion balance experiments on electric force help provide clear explanations over the electron charge, gave clear examples and diagrams. Why it was useful, could help show direct measurements of the electric force. Without the torsion balance experiments, the constant K and the behavior of charges would not have been measurable or verified. Uh, where my sources were used, the torsion balance experiment was used in slide 25, where I showed the experiment for additional. I brought up the experiment for additional information on the electron charge. It is an important experiment used to calculate the electron charge. The Briticana was used in slides 3, 8, and 9, where in each slide I used the website to help give me information on the topic. I use formulas, examples, and basic information in order information it gave over the topic.
Additional facts. Fact one, Michael Faraday showed the electric charge is quantized and related charge matter through electrolysis. Fact two, he had almost no formal education. Faraday only had basic schooling and taught himself by reading physics and chemistry books he was finding as part of his job. Other work, he established two fundamental laws describing how electric charge causes chemical change, the foundation of electronic chemistry. Collaborators, Sir Humphrey Davy, gave Faraday his first position in science, trained him in chemistry and laboratory methods. Related information, Faraday discovered electromagnetic introduction, the principle that a changing magnet field can produce electricity. Additional interest. Interesting and surprising facts about the electron charge. The charge of a proton is exactly equal in magnitude to the charge of electron, but positive. This balance keeps atoms neutral and the universe stable. What I learned, electrons have a negative charge and protons have positive charge, and their charges are exact opposites in size. In a normal atom, the number of electrons equals the number of protons. Other information on it, atoms stay together instead of exploding apart. Another one is chemical bonds can form in predictable ways. Another one is the universe isn't filled with random electric forces. The overall summary, how it went. Electrons have a negative charge and protons have positive charge. What was the most important? This was because the charges balance and atoms stick together instead of ripping apart. Most important matter stays stable. The easiest part of this project was with good partners and understanding the information and having good communication through the project. The hardest parts of the project were getting the right information and having the correct slides between different partners and understanding the main goal. Uh, what I found most surprising over this project is you can move the electrons around, but the amount of charge in the universe is always the same. That's mind blowing. Relevant sources. Uh, it's top one listed here, and the original sources were about his lectures and published works of his lifetime, such as Chemical Manipulation, uh, his practical manual for chemistry studies. Uh, the achieves knowing as Friday Pepper is held by institutes such as the Royal Institute. These include manuscripts, letters, notebooks, many which are digitalized or available for scholarly access. Why the sources were useful. This shows how his discoveries were made, what questions he asked, what tests he tried, and how he interpreted the results.
Some additional facts is the basic unit of electric charge. All observable charges come in multiple electrons. Electrons carry E while protons carry E plus with the same magnitude. The electron charge determines how electrons interact with electric and magnetic fields. Millikan's Oldrop experiment proved charge is quantized in multiples of electron. Electrons are the main charge carriers in metal.